Thank you. It's Zoran Sevarac, by the way. Hello, everybody, and thank you for joining us today. As already introduced, I'm Zoran Sevarac. I'm CEO of DeepNets and professor of AI at the University of Belgrade. And today I will talk to you about how you can put some deep learning into your Java applications and how you can make them smarter. The whole thing about AI, machine learning, and deep learning, everybody's talking about that, and it is a huge trend, and it is improving applications in almost all domains. I mean, every application out there that comes out says, we have some AI doing this or that. So for software developers, there are some challenges, how to go for it, how to create something that will really create some value, something that is really just AI, not just a few if-else rules or some basic statistics, and that the most important, that creates a value for end users. So let me start with one brief explanation about what machine learning is, because looking at the media headlines, sometimes someone might get the impression that we are having thinking machines just out of the box and they are already with us. And from the programmer's viewpoint, sometimes it looks very mystical and people are not sure how to go for it and how to think about it. Even the term machine learning is, in my opinion, a bit outdated. It was coined like 50 years ago. And with the advancement of all the algorithms and computing power, I would say that machine learning is basically a computer algorithm that is capable to automatically configure internal parameters. Now, that process of configuring parameters is referred to as learning. And the important thing to point is that this process of configuration is performed based looking on examples which are given as data. So that's what we call data set. And the whole point of doing this configuration is in order to perform some very specific task on a similar data and try to be as accurate as possible. So as you can see, machine learning cannot learn anything. It is not it is not capable still of learning higher level thoughts and concepts like humans, but it can learn some basic simple tasks that it can extract from data and try to be as accurate as possible. Now, what exactly it can do? What task it can perform? Well, there are many tasks it can perform, but most widely used in practice are basically classification tasks, which are just assigning input objects into some categories, predefined categories. Then there is a regression task, which is estimating some numeric value, for example, trying to predict sales or marketing or application performance. And the third one, which is very popular and with many innovative applications, is image recognition, which is a very interestingly using classification to classify objects and regression to determine position of object in the image. So basically, in image recognition, we are using machine learning algorithms which are being fed with image data. And these three tasks, basic machine learning tasks, have many practical applications. Here are some of them you can see on this slide. And for example, this basic classification, one of the maybe most widely used application is to predict banner clicks. So every time you get on some web page, there is some classifier figuring out which ads to display, which is most likely to be clicked by the users. So that is one of the most valuable applications today, probably. Then fraud detection or spam detection, all these transactions online, for example, PayPal would not be possible without machine learning, because the many attacks or fraudulent transactions are created in real time. So it is not possible to hard code everything with the fixed set of rules, but you need to monitor what the users are doing and how they're trying to trick the system and learn from that. Then for image recognition, you have this kind of many visual inspection and monitoring systems. Then you can automate content management on social networks, or use it is widely used in systems like self-driving cars. So that is the brief introduction to machine learning. Now, what about deep learning? What is so special about deep learning? Well, deep learning is one specific technique of machine learning, which can provide higher accuracy with more data that you give to the algorithm. So that's a big difference compared to traditional machine learning systems. And here on this slide, you can see the famous graph which was used with the famous AI researcher Andrew Ng when he was presenting and convincing Google to go for deep learning. And it shows that with traditional machine learning algorithms, with more data, you get better accuracy, but at some point, the accuracy stops growing. It becomes constant. And with the deep learning, the more data you have, you get the better performance, you get a higher accuracy. Now, it is still not completely clear when with deep learning this stops, but at this moment, it is still growing. And one very important thing about deep learning is that it managed to do this by automating some steps that were performed manually in traditional machine learning. That is feature extraction. We'll talk about this a bit later, but this is the main idea why everybody got very excited about deep learning and what is its difference compared to machine learning. Now, when Java developer wants to go for deep learning and integrate into their application, they have several essential challenges. And maybe one first they face is that they find it very complex to get started and learn. The reason for that is that this is still area in active research, and many things are still experimental and not well defined, and it requires a deeper understanding of the algorithms and their settings. So you will face many different algorithms, and leaving you with a question, which one should I use? And every of these algorithms have many settings, which are difficult to understand if you don't know how they are working inside. And there are many frameworks out there which provide many options, but the problem are not having options, but how to use or what to do with all these options. So usually people get to start learning some theory in order to get understanding, and they keep learning, but they are getting far from the application of what they really want to do. Now, today I'm going to show you this introduction using DeepNet software. There are many others available, but the DeepNet is very convenient to use for software developer, because they are designed, it is designed in that way. And recently we got a kind of confirmation that we have managed to create a design that will help software developers to use deep learning. And the confirmation that one of the our users that tried to use, get a free trial and try to use it, which is, by the way, 14-year-old boy, has managed to create deep learning for his Sudoku game in Java. So If a 14-year-old, which knows only basic mathematics, don't know even mathematics required to start understanding deep learning, and definitely no PhD or some advanced knowledge, who learned Java during the lockdown, which also means that he's a basic Java developer, and he managed to using the DeepNet's GUI and even the API, which is very convenient and easy to understand if you know basic Java, allows you to start applying deep learning. So you don't need to understand everything that's going on inside, but if you have a nice user interface, nice API, and you know the problem that you want to solve, and you know what kind of tasks it is, then DeepNets can really help you with that. So you can read more details about that and see a video on the link above. This presentation will be available after this today's session. So on this screen, you can see the screen, the main screen of the DeepNets, and you can see that it is a very familiar environment for software developers. Basically, it is IDE looking like user interface, and it provides pure Java deep learning engine. That's something that's different from others, and it provides this very developer-friendly tool. There is also a community edition, which is purely open source. So you can study how it works and see how you can apply it to your systems. And it is also important to mention that this community edition of DeepNets is the base for official Java standard, which is JSR 381, visual recognition API, which will be accepted very, very soon as an official standard. Now, you remember when we talked about these basic machine learning tasks? Here's just a quick look about how this DeepNet's wizard looks like. This wizard takes you through a series of steps and help you frame your problem within deep learning domain. So this is how the wizard asks you questions. What do you want to do? Do you want to classify data, classify images, or predict value? So from what we already explained, classify data is classification problem, classify images is image recognition problem, and if you want to predict the value, then it is a regression problem. But it does not bother end user with these machine learning terms, which might be difficult for average developer to understand, but just explaining, let's say, in plain English. Now, what DeepNets also does is guide you through a typical machine learning workflow, which is different of the software development workflow. Software development workflow is you type a code, you run application, you observe outputs, and you say, well, it works or it does not work as expected, and then you debug. You can trace step by step. With machine learning, it is similar to that, but it's not completely like that, and that's something that also might be confusing for software developers. Typical process includes data preparation, which means when you prepare data to feed the algorithm, you have to make sure that the model can learn from that data, and that is operations like normalization, scaling, standardization, and cleaning up, detecting outliers, and so on, which is typically something that is performed by data scientists and well known by statisticians, but not so much for software developers. Now, with DeepNets, we try to perform data preparation, which is known as best practice, and to free the developer from that the thinking about that. Now, model training is definitely the main step, which includes automated process of self-configuring internal algorithm parameters, and after that, we perform testing of the model, which calculates various metrics. Now, this is the moment where a software developer usually lose the focus. They don't know about this statistical classifier testing and so on, these metrics. But with deep nets, you just get the outputs and you with brief explanation. So we don't assume that the developer knows all these things. And we try to explain, again, briefly in plain English with some comments. So you can understand how your model is performing, how good it is at guessing what it is trying to guess. And of course, the important, the most difficult part would be model tuning, which means that you need to change some model parameters, and you need to change training parameters in order to get better accuracy and better results within testing. So these three steps, training, testing, and tuning, would be like debugging in traditional software development. And what DeepNets try to do is to create an environment in which these can be performed very easy with a focus on specific parameters and understanding of the how model, understanding the testing results. Now, after that, when the model gives a decent accuracy, the next step is model deployment. And with DeepNets, we just generate the model as a jar file. So you don't need to do anything else. You have a jar file, you have a Java library, and the model is ready to be deployed, maybe directly from the IDE. So one of the basic deep learning models that we'll be talking about today and that we will show is this feed-forward neural networks and also convolutional neural networks. And when you say deep learning, you mean neural networks. Now, neural networks are, you can think about them as a graph. So sometimes you will see comparison like there are brain-like structures or something like that, which is very far from truth. As a software developer, you can think about deep learning models and neural networks as a computational graph. So you have, you see on this diagram how this graph can look like with all these nodes, which are organized in so-called layers, which are interconnected. And each of these nodes in this layer performs some computation. Now, adjusting these connections makes the system learn. Now, on this screen, you can also see how this representation of this graph looks within deep nets. Basically, you have this drag and drop interface, visual builder, in which you can just stack this layer on top of each other, and you can inspect and set the properties of each individual layer, basically in a drag and drop software development style. And of course, you can inspect the source, we'll see later in the demo, and see how this architecture looks in a JSON format. Now, regarding the training procedure, which is the most important part, there are several things that help you in deep nets to inspect this process. So assume that you have a kind of neural network here, and you have prepared a data which contains training examples. The learning process is based on minimizing errors, which is feeding the model with data and then detecting how much the model output differs from the output that we want to achieve. And this difference is called error. This error is being calculated with the component of the model, which is called loss function. And based on this error, the training algorithm automatically adjusts the internal network parameters. So this error and loss function are very important components of the model. And in deep nets, during the training, we have this graph that displays error during the learning iterations. And you can see how this, on this image, how this error falls down or is lowering over the time with each training iteration. Now this training algorithm is can be tuned with many different options, and all these options can be changed and adapted within the simple properties file, which is also provided now by the deep nets. In this link on this slide, you can see you have a very friendly tutorial which explains deep learning from very basic concepts for machine learning very quickly, and you get to understand this kind of uh, type of machine learning, which is, by the way, in literature also known as supervised machine learning, and which is, I think, like 70% of applications fall down into the supervised machine learning. Now, we mentioned at the beginning that one of the most popular applications of deep learning is image recognition. And this is the model which is based for all these advancements is called convolutional neural network. This convolutional neural network is basically extension of a basic neural network that we also showed on this previous slides. And it is based on a very simple idea that we have a classifier which is used as a to classify input features, and usually it is this kind of feed-forward neural network. And before that classifier, we have a block which performs feature extraction and feature detection. Now, this feature detection is performed by so-called convolutional layers, which are very close to Photoshop filters. You know, all these effects in Photoshop which perform, they find edges or invert images or put some effect. Well, it is performed with so-called convolutional operators, which are small matrices. And the whole idea of convolutional neural network is to use these filters to find important features in the images which can be used to distinguish between different objects. Now, the big breakthrough is that finding these features is being automated using the same algorithm that is used to train these feed-forward networks, and that really increased accuracy and practical applications. Before we have convolutional neural networks, people have to do manually to design these features and to try to figure out what should be used, and that involved a lot of experimenting, and it was very difficult to do. Now, with automating this process, we have increased the accuracy a lot. So I'm going to show you now one example which has an interesting practical application, which is parking lot occupancy detection. There is a data set available which contains patchy images with parking lot spaces with occupied and not occupied parking spaces. And these are manually labeled from the cameras of the parking lot. And these images are used to train convolutional neural networks, which gives output for the given image, can give output, or this parking space is occupied or this parking space is not occupied. Now, the example that I'm going to show you, it was created, it was firstly published in a research paper, which is this deep learning for decentralized parking lot occupancy detection. And it is using AlexNet, which is a very big neural network trained by on GPUs and lots of images. But the implementation provided by DeepNets is pure Java. It is not using GPUs. It is using CPU, multi-threaded implementation on the CPU, and it is much smaller. So with a much consumes less computational power, so it can have some interesting advantages for practical application. Now, let me just, can you see this application? I guess you can. I'm sharing the screen. I'm going to show you demo. This is what you see is DeepNet's UI. And we have this project-based workflow. So we are just creating a new project. See this screen. What we want to do? We want to classify images. We go on the next screen. And then we want to perform binary classification because we have two types of images: occupied parking space or not occupied parking space. It's binary classification tasks. Next, we choose, we direct images, and here is the prepared image data set. So you can see how these many images of these parking spaces. So you can see there are some images with different, with trees, with different angles, with different lighting, and all these variations makes very difficult for traditional algorithms to perform this kind of recognition. And we have a bunch of images which present not occupied parking space. Now we select this directory with images, and basically DeepNet automatically detects all it needs to detect or generates files or whatever it needs. And one of the typical things that you do with image processing is to scale these images. Now you would need to be expert for this image processing, but with DeepNet you can just perform these few options and it will automatically be done for you. Now let's create like a small convolutional network with this wizard. Let's say that we will put like I don't know, that's 3 channels for start, or maybe 6, better. And then put some these fully connected layers. Now this is the moment where typical developer does not know what to do. So as you can see, some of these inputs are disabled, and if you put mouse on some options, you get this kind of explanation of what the specific option means. And if you don't know what all these additional settings mean on first run, you don't have to bother. You can just say next, next, and finish, and it will automatically set all the settings that are like some kind of reasonable defaults. And as you can see, you will get all these projects files created. They are given as a settings in properties file, which are very friendly for Java developers. And there are some, even some autocomplete options. We are working on documentation. So this is the settings for the data sets. This will be the settings for the training. And this is the network architecture given as a JSON file. It's very nice and readable. And you can also have this kind of visual view of the network architecture. So in order to run, you just run this file. We can also turn on this visual layers. I don't know how it will be on this over Zoom, but let's try it. Or better not. So now what it is doing, it is loading images and pre-processing. So this will take a few moments. We'll observe the results. Okay, so it has loaded images, it is created the network. Now it is training, and you can see 2 graphs which will be updated during the training, which will show the network error over the epochs and the network accuracy also over the epochs. So the goal during the training is for error to reach like a specific minimum, which can be specified in these training properties, which is maximum error. We say 0.03, which is like 3%, and depending of the size of the data and the complexity of the problem, it can take a while. And as you can see, the initial error was 0.7. And after first epoch, after first pass of the entire data set through the neural network, the network training error was lowered down to 0.06, and the accuracy of a network was 0.99. Now this is very simple problem, and a small network. It should definitely be used like a bigger, but in order to make this quick demo, I use this small network. But as you can see, we got very high accuracy, which is 99%, even 100%, with a very small network and very quick. Now, I don't know if you can see this. Let me just put it like in focus and maybe increase a little bit. So here are the results of testing the network. These are these various evaluation metrics, which I mentioned that might be confusing for software developers. And the accuracy is how often is classified correct in total, whether it is predicting occupied or not occupied parking space, which is positive and negative class. We get this 99% even with a test set. Now this is something that I haven't mentioned. You're training, when you are given entire data sets to create a model, you're using a part of the model to train the network, and you're using the other part or the rest of the data to test the model. Now this is being specified in these properties. We see this test setting, train test split 70-30. So we are using 70% to test the model, to train the model, and 30% to test the model. Now, even with the test data, we get really good accuracy. Then precision is important metric, which is how often is classified correct when it gives positive prediction. When it says it is occupied, how often it is correct. And the third metric is recall, which is when it is actually positive class, how often it gives positive prediction. And I think we are overfitting, so-called overfitting here, because it is a very, very small network. But even that, we are getting a very good result. So this is so-called confusion matrix, which is used to present the overall performance of the classifier, how often it is guessing the negative and positive examples, and these are the metrics which are calculated from these confusion metrics. So we can even play with this tool which says which provides test image tool, and the trained network is created here with DeepNet, and we can see perform this. Say we want to test this network, and we want to use this data set to test it, and then hit images. It will take just a few moments to test it, and it needs to finish. This example shows you that just following wizard, you can create like a very simple image classifier, which is ready to be deployed within Java applications, some kind of parking management Java applications, or if you have any kind of other need for image recognition, you can create it very easy. And you can see that these results for images, how it is recognized, busy, and confidence in output is 99. So this is negative, not the busy, right? Recognize negative, and you can observe how this how it actually performs on actual images. So this is a car, and you can see this image and this image are very different, and it would be impossible to create like a some hard-coded algorithm that can solve all these variations. And if we want, we can take to display only false predictions to see what this algorithm did not recognize well. And it will be interesting for you to notice that these are usually images with very, very dark images, which are taken by night, and which are all black, which confuses the algorithm. Okay, take a moment to process it. So since it is pure Java and CPU only, sometimes it takes a while to calculate, but we are working with the Tornado VM team to create the GPU support for this also. So you can see this negative, the pictures that it has missed. So this is one which is too white. This should not be missed, but it did not recognize it. Now this one, it is understandable why it is missed. It recognized this tree, this shadow as a car. So this example showed you, explained you some basic concepts to understand the flow of the machine learning and deep learning, and explain you what are the important points to do that. And we have example of parking lot application in a source code, which is using DeepNet's open source community edition. So you have this link on a GitHub, and this is how this using it from the API looks like. So you're adding this input layer, configuring all these parameters. So you can see why it might be difficult for the first time to understand what is going on, because there are many parameters to set, and UI, doing it firstly with UI to get some experience, I think it really helps. And this is like a builder pattern, which you stack a series of layers, and then you have this training algorithm, backpropagation trainer, which sets different learning parameters and perform training. At the end, you have this evaluation, which is also with a one method call. So this is very specialized, very minimum API that gets you do the job. And experimenting with it, it allows experimentation, but you can do very specific things like using convolutional networks and feed-forward networks. Many other algorithms which are provided with other frameworks are not supported, but they are very specialized and easy to use for these tasks which are most widely used. So we have also already shown you this demo, and the entire demo is available on the video and blog post on this link, and you have links to data set and the original paper. Now on this slide, you will see how loading and using trained neural networks looks like. Basically, you have this file IO class which provides various utilities to create neural networks and data sets from file, and you specify the saved network and specify what class it belongs to, and you get instance of trained network, which can be either created using GUI or can be created from Java code, as we saw it in the previous example. The next thing is to wrap that neural network in a convolutional image classifier, which is implementation of a visual recognition API, which is standard API for classification, for image classification, and which is using convolutional neural network as a backend. And you simply just put this instance of a trained network in the convolutional classifier. And in order to classify image, you have something very simple, which is image classifier dot classify, and you put image into it, which can be in file, or you can get it from internet or wherever you like. And what you get a results which corresponds to a map with the object names and probability that it belongs to some objects. So basically, once you have a trained network, you have 3 lines, 3 steps of code to perform classification, which makes it very easy to integrate. And since it is using standard Java API, and it will evolve, if some new models come out, they will be supported, and it will be you can innovate, you can change them without changing your application code at all. So that is one of the things why the standard API is really good for. So since I mentioned it in the announcement or presentation, I just quickly go through example with data classification. The previous example was using images, but if you have something like data, which you can get from CSV file or from database, you typically use this kind of feed-forward neural network, and which is very similar, which is a base for convolutional networks. And in this task for data classification, you want to decide whether some email is spam or it is not spam, something that we see every day, with a certain probability, because you cannot be 100% sure. Sometimes, all these filters make mistakes. And this is how you would do it. You have CSV file with tabular data, which contains frequencies of occurrences of certain words in email, frequencies of certain characters in the mail, and frequency of all capital letters in the email, which is typically characteristic for spam emails. And this is the piece of code that creates a feed-forward neural network. As you can see, it is very similar to one example with convolutional network. It's like a standard based API, which said feed-forward network.builder to get a builder for specific model, and that then to add all those layers. Now the full tutorial with explanation for creating this kind of classifiers from CSV files, which can be spam or any other data you have from CSV file, is available on Oracle blogs. And also you have a complete source example on GitHub, which is implemented with this community edition, with open source edition of DeepNets. Now, this is something that I already mentioned, won't take too much time, but this DeepNets Community Edition is based for implementation of this standard Java API, and it will be released very, very soon, I think till the end of this month. And the thing is, the goal of this API is to make it easy for Java developers to use machine learning and to use visual recognition from Java. It provides basic machine learning abstractions and try to free the Java developers from need to understand all the details and implementation of the machine learning algorithms, which is basically Java philosophy in general for any technology that Java goes for. This is the idea, the general architecture of the visual recognition API. And as you can see, we have this public API, which relies on visual recognition layer. And the most important part is this generic ML layer, which provides abstractions for classifier and regressions. So the key for this architecture is that we have used service provider infrastructure. So we have enabled different machine learning engines to implement this API. And DeepNets is the reference implementation. And there is also one more implementation provided by Amazon, which is DJL implementation. So we have also interest from significant big players in this field, which see how this API will simplify and improve development of machine learning applications on Java platform. So this is how the Java code for doing this parking lot recognition looks like in a visual recognition API. So as you can see, it has less code, and we have image classifier using buffered images. So we are getting inputs from buffer images, and following a similar pattern with this builder, we have created this image classifier. So we have reached the end of the session, and I'm open for your questions now. And at the end, I would like to invite you to try to download and try DeepNets. You can learn a lot of it, and you can learn how to make these first steps. And even if you want to do something in Java code, you can use DeepNets Community Edition. Of course, you can use this from free trial, which is, by the way, much faster and provides better accuracy. And only for the participants of this session, there is an opportunity to, if you build some interesting pilot project and write a blog post about it, like this 14-year boy, which we mentioned, and you can get a development license for free. So let me know if you have any questions now.
Zoran,
yes,
there is no questions for now. We will let them for 5 minutes. If they want to ask questions, they can do it in Q&A. And after 5 minutes, we will finish the meeting if nobody has any questions.
Okay, thank you.
And thank you for everything, Zoran.
Thank you for having me, for the opportunity to talk here. And if you don't have any questions, like we can chat, I will be really interested to hear what are your interest in deep learning from any participants. How do you see it? What are your experiences? Have you tried it? What were the challenges that you had? What would you like to build using deep learning? Or if you have very specific questions, how to build something that you need, it's all okay to ask.
Zoran,
Yes.
Next year we will have 2 Hrov conferences. One will be in beginning of May as new one. Of course, this COVID pandemic will allow us to do that. And second will be traditional in mid of October.
Oh, great. Yeah.
That's it.
I'll be happy to participate.
Yeah, thanks.
Okay, we have questions. Do you see them?
Yes, first with the use cases and customer reference, we do have like a use case. It is being used by one institute in Germany for testing materials. I cannot give the details, but we have not promoted it widely yet, so we don't have many customers at the moment. Only like research prototypes used in education and at universities, and we hope like in next phase we'll get more customers and some real production usage. So restrictions of the community edition. The community edition basically it has almost all the features. They have basic features. It is slower. It is constrained to a single thread, and it does not support all the algorithms. And maybe the biggest restriction is that it does not provide this tool. It does not provide GUI for training neural networks. But as I said, you can use a free edition, and you can even get a free license for development purposes if you like to create a prototype and write a blog post about it. So we are just in an early phase of bringing this solution to the market. It is really new, and so far we get the very good feedback from the Java community and Java developers. It feels like there is a need something for a tool like this, and if you have any suggestions, like in which direction, what would you like to have, what features you need, and what kind of use cases this would be interesting for. We would really like to hear that. So that is our goal. And by the way, I didn't mention that this development tool is based on Apache NetBeans, so it has like a very IDE oriented, and it is modular. So we see the further development of specialized plugins for specific solutions and use cases.
You have one more question in the chat, and then we will have to finish.
Mm-hmm. Yes, I think I in the chat. Hello, why is it called DeepNet since it's conventional? Well, DeepNet convolutional neural network is a deep learning. It's basically marketing term, because having more these layers makes the network deep, and also deep is learning from these features, these convolutional features, which are trainable feature detectors, which are performed by manually before. It is it is what makes the learning deep. So it is not just learning classification, but it is also learning how to extract features. But basically, it is the same. Technically, it is the same as neural networks. The term deep learning came out, if you ask me, maybe even for marketing purposes, but there are differences.
Thank you, and see you on Chrome, I hope.
Okay, thank you very much. I'll thank everybody for attending.